Yes.
He was the head of the Richmond Technology Center, Chevron's Richmond Technology Center. He's got PhD in chemical engineering. PhD in chemical engineering. His PhD work actually made it into textbooks in chemical engineering, I'm told. That's pretty non-trivial. He's also a distinguished alumnus of IIT Madras. And he's going to be the moderator for this fireside. I'll let him introduce our distinguished speaker.
Sure. Yeah. Thank you. So I'm going to do this very informally. I've chosen to introduce Amit. His bio is so long that it'll take up all of the time here today. So I'm going to do this without looking at my cheat sheet. So let's see how I do. So Amit went to IIT Kanpur. Correct me by the way if I miss it. IIT Kanpur, BTech in electrical engineering. Came to Berkeley, got his PhD, and started a company called Berkeley Design Automation, BDA. And this is a company where he's a co-founder or founder, CEO, and they help design software for semiconductor design. And they got broad utilization. I think it was the top 100 semiconductor companies in the world used his product. And in fact, he got an Innovator of the Year award in 2006. Okay, I got that right so far. Let's see. Then he joined a company called Magma Design Automation as the vice president of product. And once again, his team worked on products that have broad application. Again, I think this time the stat was a third of the semiconductors used in consumer electronics utilized the products that his team developed. From 2010 to 12, he was director of smart grid research at Stanford. And then he started, he's a founder and CEO of AutoGrid in 2010. So he'll touch a little bit on AutoGrid during his talk, and then we'll probe some more during the fireside chat. Okay.
Thank you, Ashok. It's obviously a great pleasure and honor to be here. And Ashok said that we are paying you the big bucks to come and entertain the crowd in the afternoon. Make sure that you keep them energized because there's fantastic food out there and then it's hard to keep people sort of focused. So I thought, what better thing to talk about than electricity to energize people. So that's going to be my the focus of my talk actually today. And if you take just one thing away from this entire presentation, I just want you to remember that electricity is actually the most happening place right now in the industry. It's not your 100-year-old sort of image of utilities. It's not the power systems courses that everybody used to sort of run away from, at least in my IIT days, because everybody was looking at computers and electronics at that time. There's a lot of action on the funding side, a lot of startups coming up all the time, all the big companies are moving in. So what I'm hoping to do is to just give you a flavor of what's happening in the industry. I won't talk too much about what AutoGrid is doing, but it touches upon some of the things that we are working on, but just generally a broad overview of where things are. So as I said, this is an industry which has been actually so successful that it has been a victim of its own success. I mean, most people think about energy for their utility company for less than 10 minutes during a year. And if you think about it, even before Uber and before all the on-demand things, this is the ultimate on-demand network that exists. You press a button, electrons show up, you don't even have to wait for it. And this is also the ultimate subscription model. You pay only as much as you use. And what happened was that because the industry was so successful over time, the focus actually shifted towards safety and reliability and just squeezing more and more efficiency out of it. And then, I mean, some of the vitality and innovation started slowing down in this industry. But now, for the last, I would say, 5 years or so, this is again a very, very happening place. And there are two sort of fundamental drivers which are causing so much excitement. So the first trend that I talked about is decarbonization. So we have about, if you look at various projections, we have about $10 trillion of investment that is going to happen over the next 10 to 15 years to move from a fossil economy to a renewable-based economy. And that includes both wind and solar as generation sources, but also includes things like battery storage, which is, I'm going to talk about that quite a bit, and battery both in terms of stationary storage as well as mobile storage in electric cars and so on. And the other sort of big trend which is happening is what we call decentralization. So this is like moving from your landlines to your cell phones, which means that people are not just relying on these large centralized fossil fuel burning generators. They are actually putting a generator on their rooftop, so they can buy solar. A lot of these, if you're a commercial industrial customer, you can put solar, a combination of fuel cells or CFP, and along with the battery system and demand management, you can actually be self-sufficient, and not just self-sufficient, you can be more than self-sufficient, you can provide electricity back to the grid. So this whole notion of consumer is changing into what we call prosumers now. And the role of electricity company, which was always, we just build more and more generation and more wires to carry the electrons, is changing from a supplier to an energy service provider. And this is, so if you just stay back. So what's happening here is that these energy providers are now thinking about full energy value, or all the energy needs that the end customer have is trying to provide that. So the game is shifting from this capital investment to a much more intelligence optimization of how electrons are managed in the supply chain all the way to the consumers. And that's where I think we'll talk a lot about AI and big data and machine learning, which is going to start coming in. But it's also about business models. And this is where I want to spend some time, where the model where you just build big power plants and you say, now I'm going to sell electrons, and these are commodity electrons, so I'm going to get a markup on that, is getting turned on its head. Because if you think about it, in the old days, every time you produce an electron, you have to burn fuel, and there's a marginal cost of that electron. So you can create a business model which puts a markup on that electron. But now, as you get into the renewable world, the marginal cost is zero. You don't have to pay an extra dollar to produce an extra unit of electricity. And once the asset gets depreciated, which may happen over 10 years or so, even the real cost becomes zero. So it's very hard to get a markup on a commodity which is going to zero. So really what's happening is that now the business is shifting from providing electrons to finding arbitrage in the whole demand-supply value chain. And that arbitrage happens because these new sources of generation have very high volatility. The wind doesn't blow all the time, the sun doesn't shine in the night, the demand patterns are fluctuating all the time. So balancing supply and demand at every point, at every node, at every second is something that creates opportunities. And we call this problem of as flexibility management. How do you make sure that this network can be balanced 24/7, 365 at all possible nodes? And this creates a whole set of new business models, which if you go to the next slide, actually just build up the whole animation, that will be easier. Yeah, sorry, I mean, it's hard to control it. But basically, if you look at the whole value chain, you have energy consumers, you and me and big buildings and various types of industrial consumers. You have some suppliers, typically these are the customers of our software. And then these suppliers are generally sort of buying and selling electricity from wholesale markets, and they have to manage their own grid. So these could be independent retailers, just like a cell phone provider. Now the entire business model across the world is based on both what the consumer gets to pay or see, and how the energy suppliers make their money. So on the consumer side, you have an electricity bill, and most people probably don't look at their bill. I mean, generally residential bills are fairly straightforward. You have an energy charge, you have an access charge. Once you start getting into commercial industrial facilities, the bills get a lot more complicated. You have things called demand charges. So even if you're using a large amount of electricity for a very small period of time, 70% of your bill may happen because of that 15-minute interval. So what the energy companies are doing is that they're saying that we can give you a different rate plan, and that rate plan will reduce your energy consumption and demand consumption. And to be able to do that, we might install some hardware, maybe some batteries, maybe some solar panel, maybe some CHP units, but you are going to save money. And you're not just going to save money, you're also going to get more resilient power, you'll get backup, it's going to be cleaner power, it's going to be much more sustainable. But at the end of the day, you will save some money. But to do that, I'm going to get some sort of a fee, which is what I call in this model flexibility payment. This could be a markup on the finance that I provide on the hardware. There are many ways in which this fee can be extracted. And then they turn around and they say that, okay, for me to serve you, I have to first find you, which is a big cost in solar and any distributed energy technology, the cost of customer acquisition. And I need to put all this investment in various technologies. So sometimes they get incentives. I mean, incentives are still a significant piece of the value proposition in many parts of the world. Then they get the flexibility payment that is coming from the customer in some form. But in most markets today, these two value streams may not be sufficient to make the business case viable. So in that case, they go and say that I'm going to find these arbitrage opportunities that exist in the market. So I'm going to, like, I don't know how many of you were following the Texas power prices this summer. There were 25 hours where the prices were $9,000 per megawatt hour, when actually average prices are about $20, $25 per megawatt hour. So those 20, 25 hours can actually wipe out a full energy retailer in that market. So there are lots of hours these days as wind penetration is increasing, where the prices become less than zero in the market. So there's quite a bit of trading arbitrage that's available in these markets. So you can go and sell in the wholesale market. And at the same time, when you look at the grid infrastructure, and I think one of the professors in the previous talk was talking about how they can't push water through the pipes because the pipes are not configured correctly. Same way, when you are trying to push electrons, there are these pockets of congestions. And when your energy consumption during the afternoons in the summer is much higher than what's in the nighttime. So you get these issues where you have to make a lot of infrastructure investment to be able to meet 24/7 reliability. And what utilities have started doing is that instead of building much more very expensive infrastructure, they're asking consumers to participate by managing their demand. And there are significant incentives available for those things. These are called non-wires alternatives. There are many different types of grid services that are out there in the market. So an energy company can go in and contract with a utility like PG&E or Southern Cal Edison to get initial money. And now if you're able to stack all of these value streams, then you can see that there is a very, very viable business model in the market. And that's really what is happening across the board. If you go to the next slide, this general model is something which is happening everywhere in the world right now. It's valid in US, it's valid in Europe, it's also valid in Asia. In fact, Asia is one of the fastest growing markets. India itself, we will touch upon some of that, right now uses more than 90 gigawatts of diesel generators. And the cost of solar plus storage today, without any subsidies in India, is less than running just the operating cost of diesel. So these numbers are, it's a global trend. At this point with AutoGrid, we are working with companies over 12 countries now. We constantly get pinged by companies in different parts. We just signed a deal in South America. We are looking at some deals in Africa. So this is the general business model that I described is basically the Uber type of business model, right? You have these underutilized assets which are sitting there, and you can rent them to the grid, and they can make money. So it's the self-driving version of Uber, which means that you don't have to go and change the settings on your thermostat, or you don't have to change how the battery is working. It's actually just doing the work and generating money for you. And so that's really how IoT is sort of transforming how the business models in this industry are working. So I also wanted to, because I know we have a lot of brain power in this room, I just wanted to talk about why this problem is hard and why we need more people like you are sitting in the room to start thinking about it. If you just look at a single site, right, one home or one factory, that itself has quite a bit of complexity, and this complexity grows very quickly. So you have loads which you can control, like, and within that you may have AC systems and pool pumps and water heaters and EVs and so on. Then you have generation, and you may have different types of generation. You may have backup generation, you may have solar PV, you may decide to put a battery, and then most of the times this is connected to the grid. Sometimes it may not be connected to the grid. Sometimes you want to make sure that you can run without grid. And this environment itself has to take into account a lot of different details, like what is the chemistry of battery, how many cycles can you do on this, what's the round trip efficiency of this battery, what's happening in the markets, what are the utility rates that I'm trying to optimize against, what is the what's going to happen to my PV generation or load in the home. So if you go to the next slide, we have to make this decision 24/7, and we have to make sure that all of these constraints are managed. But this problem becomes really interesting when you realize that this is just one out of maybe 100,000 or a million sites. Just to put this in context, today the entire utility system in the US has about 9,000 odd generating units. These are very large generating units, but I mean, relatively speaking, there are very few of them. When you start moving to a distributed system, you will have millions, maybe tens of millions of these very quickly. We are already seeing hundreds of thousands, and very quickly we are going to get into millions of these. And what happens is that as the number of sites increase, your computational complexity grows very, very significantly. And this is the classic sort of big data problem that happens here. If you are looking at traditional sort of SQL type technologies, relational databases, at around 1,000 or so assets, you start hitting the knee of the curve, where it's hard to do real-time optimization for a large number of assets. And so you have to sort of, I mean, this is a place where we were one of the first ones to realize that this, we are going to hit this wall and we need to do something about it, and started saying that we need to use all the techniques that Google and Facebook and internet companies have developed to deal with massive volumes of clickstream data. We have to bring that into the energy domain, and we have to build a platform from scratch. Now this is a slightly more complicated problem, actually quite a bit more complicated problem than just doing big data and AI as most people do it, because here you are not just bringing in the data and doing predictive maintenance or looking at forecasting what's going to, what might happen once. You are actually solving an optimization problem continuously, and you are solving it at multiple time scales. So you have to do all the things that we have learned from large-scale system optimization, like figure out how to solve DAEs and how do you do high-performance numerical computation, and do that in the context of big streaming data that is coming in. And if you think about it, these two paradigms of computing actually have evolved somewhat independently. When I was doing high-performance computing for semiconductor design, you would do your simulations offline, but you are not doing that HPC as the data is streaming in. And when you were doing machine learning and so on, your data is streaming in, but you are really not optimizing something at that level, essentially. So how do you bring these two things together? I think we have an architecture to do it. By no means that's the last word on what needs to be done in this industry, and there's quite a bit of richness in terms of how these problems can be formulated and be solved over time. So I'll just leave, maybe do a few examples on what people are doing. So as I said, this is something where everybody is now seeing gold, and there's a massive gold rush happening. And we work with all of these companies, we work with a number of them, but on one end, you have the traditional oil and gas majors. They are also, whether you call, I mean, there are different views on how serious they are about the new energy. I have my own view. But generally, if you look at European oil and gas companies, they have been very aggressive in sort of taking a market leadership. Shell has already gone and said that they are going to be the #1 power supplier in the world by 2030. Total is putting in $1 billion per year just in France, and they are operating in pretty much all parts of the world, from India to China. So they're making massive investments. Now these investments are still small compared to the oil and gas investments that they're making, but they are sufficiently big to move the industry forward in a very significant way. You look at Asia, 60% of new energy investments, more than $6 trillion, are going to happen in Asia. Just Southeast Asia has more population than Europe or US, and they have capacity issues. They are growing so fast that they need more energy of all kinds. So they are making major investments. We have an investor and partner called China Light and Power based out of Hong Kong, which is also one of the top 5 power producers in India when it comes to wind. These guys are building 10,000 microgrids. So they think the market for microgrids is massive. There will be 10,000 microgrids in China that will come up over the next decade. They want to participate in that. Industrial customers like Schneider are moving up the value chain. They are going to a customer like ServiceNow and they will say, if you're paying more than 50 cents per unit of electricity right now, we will come in and we will actually give you the same electricity for 12 cents. It's going to be cleaner, it's going to be much more reliable, and we'll finance all the investment that we need to do. And then, so the utility companies are losing that customer to Schneider, and Schneider, which is an equipment provider, is now moving up the value chain. And then Amazon, is obviously everywhere. I'm sure some of you work for Amazon as well. They're both a large consumer of electricity in their data centers. If you look at the logistics and supply chain, they just announced Rivian with 100,000 trucks, which is going to be transformative for this industry. They are already looking at how to become much more entrenched in the energy space. And the big trend which is happening across multiple verticals is around digital transformation. So when it comes to digital transformation, Amazon has a very, very strong position there in terms of AWS and cloud and so on. So I think it's not just, if you go to my next slide, it's not, right now, it's really every part of the ecosystem, whether it's the traditional utilities, whether it's the consumer and industrial companies, whether these are new oil and gas companies or telecom companies even, and cloud companies, they're all sort of converging on this massive multi-trillion-dollar opportunity. And at the center of this is really, actually, I think there was one more animation. So it's really AI. So maybe that is. So I'll just leave with that. I think that, throughout history, we have really, every time we think about energy, we equate it with consumption of natural resources. And now, I think we are entering a world where data is the new source of power, both literally and figuratively. And it's good because data is the only source which is still growing. So I just want to leave you with that and see how you guys can use your expertise in this area. Thank you.
Thank you, Amit. Yeah. So in preparing for this, I was watching all the YouTube videos of Amit's speeches, and the way he usually ended his talks was saying, just like Amazon is putting all the department stores out of business, energy software is going to put all the oil companies out of business. Please don't say that. I spent 40 years in the oil business, so he didn't, so thank you for that. But let's see, how much time do we have? You have 4?
Till
4 o'clock?
You have
Okay.
till 4.
I had big 15-10 minute placard. You don't have that?
Not yet. So,
That's because
So anyway.
it's okay. We needed to do that.
Oh, okay.
yeah, so let's get started. So just to warm the crowd up, just a little bit about your background growing up in India, IIT Kanpur. By the way, we did some work with Professor Dande.
Oh, yeah.
So we did some collaborative research, which is a topic of today.
Great.
And then you're coming to America, Cal days. Just kind of warm us up with that.
Oh yeah, pretty normal. I think I had a really privileged upbringing. I spent more time than probably any one of you on the IIT campus because my dad was a professor himself, and Professor Dhande was one of my neighbors actually, just next door. So once I appeared for IIT, I got into IIT. I decided to stay back in IIT Kanpur. And I took electrical engineering at that time because all the professors thought that this is like where you learn the big picture, and like computer science is just a very specialized thing. It may not really go anywhere. And in IIT Kanpur, at least in those days, electrical engineering encompassed both electronics and power systems. So just like all other students, I never thought I'll actually ever work in power systems, basically. So we did the mandatory courses, and that was pretty much it. And then, life has a really interesting way of connecting the dots. But once I did the whole electronics and satisfied my curiosity with semiconductors and all that, I was looking for the next big challenge that we face. And my big realization before I started AutoGrid was that laws of physics don't change, and the same laws of Kirchhoff's that work at the chip level will also obviously work at the power systems level. And in my PhD and also the first company that I started, we were solving really large-scale electrical systems, right? I mean, if you think of a semiconductor chip, you have tens of billions of transistors, and signals are running so fast that every small metal line behaves as a transmission line. And all the technology that was used to keep up with Moore's law growth never got applied to power systems. So that's how, I mean, I made this literally 10-slide PowerPoint presentation saying that laws of physics don't change. I know how to solve DAEs. And I can do this. And I mean, fortunately, I mean, there's a place called Stanford in Bay Area where they like to bet on crazy ideas. They said, oh, I mean, this sounds fantastic. Why don't you come here and start a research group in this area? And so that's how I sort of got going.
Yeah, I watched one of the videos in which there was an aha moment.
That's right.
In a talk in Stanford. Was this Steve or someone?
Yeah, Steve McGlash. Yeah.
You said something clicked, and it's just kind of how startups happen.
Right.
So you went from semiconductor design to...
Yeah, I mean, I had like, when I sold my first company around those days, I had like 2,000 people on my LinkedIn, and I had 0 from a utility, like literally. And now I probably have 7,000 and 3,000, 4,000 are from like energy utilities. So didn't know anything about this place when I started.
So I'm going to ask you this question
Yeah.
because I think I was introduced as a guy who spent 4 decades in the oil business, right? So I read an article yesterday. It's reports on an Oxford Institute study about the strategic challenge facing the oil companies. And that is, you got to navigate 2 large and contradictory global forces, growing societal, political, market pressure to cut emissions on the one hand, and the strong likelihood that significant volumes of oil and gas will be required well beyond 2050, right? I know Chevron struggles with that. In fact, I was challenging Professor Satya. I saw him walking here. I said that when your electric plane carries 350 people across the globe, give me a call. But until then, you need jet fuel,
That's right.
You need asphalt. You need petrochemicals for textiles, multi-use plastics, right? So, how does if you were sitting in Chevron and Exxon, and I know that the guys in Europe are actually being more proactive.
Right.
I don't know if it's the environment there, the regulatory environment, I don't know what it is. But if you were sitting in, let's make Exxon, just to go away from Chevron. So if you're sitting in Exxon headquarters in Woodlands in Houston,
Right.
what would you do? How would you deal with this?
You know, I mean, I'm glad that I'm not sitting in that. It's really a classic, I would say, innovator's dilemma in some ways, right? Because you have a big business, that's the bread and butter, and I mean, the world depends on it. We, as a society, would not have been in this state if not for the energy that we have harvested from fossil fuels. But on the other hand, business as usual cannot. I mean, even if we need it, like the reality is that we have more oil in the ground than we can afford to extract from an environmental perspective. So something has to change. Now, I don't have answers on how everything is going to change, but there are a few places where it's almost no-brainer now where transition is going to happen. So I think electricity, which takes about 25% of emissions, that's on a very clear path towards decarbonization. And that's just a matter of time. Solar, wind is much cheaper. There's a lot of innovation happening in batteries. And along with the fact that battery deployments are going to massively increase with EVs, I think we have a pretty good handle on how electricity sector is going to get decarbonized. And then along with that, I think transportation and buildings will get decarbonized as well because the costs are coming down. So that accounts for about 40–50%. The other 50%, I mean, agriculture is a big part of emissions. You may need some solutions like we heard from Bloom in the past on how do you take those emissions and convert it. Carbon sequestration is probably going to play a role because you have to produce these things, they produce carbon. So I think, I mean, the big oil and gas companies, at least in Europe, both Shell and Total have invested in our company. I think they are doing what the business school has taught when we got faced with these classic innovators dilemma. They are working on their business, but they're also hedging their bets. They're creating their venture groups, they're making investments. They're letting them run more or less independently. I have not seen any reason to believe that they are just doing lip service and they're not serious. I mean, they are actually genuinely making an effort, but they have to deal with the realities of the rest of the business.
Yeah, I promised him I'll get him in front of Chevron.
Yeah.
I'm planning folks here pretty soon, but there's a famous quote from Sheikh Yamani during the oil crisis, oil embargo in the 70s. they said the iron age didn't end because we ran out of iron.
That's right.
Right? So the oil age is not going to end because we run out of oil. We're going to leave oil on the ground, right? So just to be more pinpointed, so I looked at the stats this year, 2019. So we use about 4 billion kilowatts per hour of power every year. 63% of it is still fossil fuel based. And we've actually, our CO2 emissions have actually dropped because half the coal plants have been converted to natural gas. And I think that is going to happen. Marketplace is going to drive that no matter what happens in West Virginia. That's going to happen. But if you look at the rest of it, there's 17% renewables. About half hydro and half wind. And solar is 1.8%. Right? So the last decade was a decade of transforming from coal to natural gas. Right? I even did the math. If you got India and China that are dependent 75% on coal, to go just to natural gas, which is half the carbon, you meet all the Paris rules. So obviously you can't do that. They don't have any gas. It's too expensive to ship the gas there. So in your view, I don't know, you want to speak it globally or US-wise, how do you see this? So let's say solar is 2% now. When do you see it getting up to, say, 20%? How long will it take? I think Shankar's technology will help.
I mean, if I knew that, I would be doing something else. But I mean, I think some of these things are step functions, right? So when it makes sense for everybody.
Yeah.
It's not necessarily like a linear adoption cycle. And even if you look at this historically, every projection that we have had around solar and wind, we have beaten it basically, right? So, I mean, it's faster than what people expected even 5 years ago or 10 years ago. And we are indeed getting to a tipping point where today, unsubsidized, like I was talking about India, 90 gigawatts of diesel, which is there for power generation. The OPEX of that, not the iron that you have to put in ground to start the diesel, but just running and with all the other, not even counting the theft and all that goes with it, that is more expensive than solar plus storage. And if you look at India, a lot of power outages are very predictable. They happen 3-4 hours during the day, every day. And all of those use cases are cheaper to run on. And once you start solving the storage issue, which I think we are again very, very close to solving. Maybe some long duration requires some more work. There are obviously some corner cases there, but the mainstream is that use cases in Asia, for example, on solar and storage are very, very attractive right now. And in US, I just analyzed a hospital building for one of our customers. These guys will save 10-12% on electricity. They get full backup, which they don't get from the grid right now. They get 100% clean energy. I mean, there is no trade-off basically. So why would anybody not do this? So anytime you are paying more than 12-13 cents, which is a big part of the world right now, you would go to solar just on the distributed side and then augment it with storage or some grid as the need.
Just a quick follow-up, Amit.
Yeah.
Back to India and China, I think Vinod Ghosh would say Chindia test, right?
Yeah.
It doesn't work in India and China.
Right.
2.5 billion people, forget it.
Right.
So if there's 75% dependent on coal plants, and both countries are still building coal plants.
Right.
How the heck, and solar is cheap, right, for sure, cost is coming down. But how do you turn that curve? I mean, that just seems like...
I think it's turning, but there are some structural issues. This is obviously a regulated environment, and I mean, India has this unique issue. All the distribution companies are bankrupt, and they are not credit-worthy counterparties. And so the cost of finance is extremely high there. We were doing a project in Andhra Pradesh ourselves, and the government came. These guys are like going retroactively and cancelling all the contracts. Like
the opposite of what the...
Yeah, right. So, I mean, and if you put a solar plant or a wind plant, which is a 15-year plan, and then somebody goes and says, by the way, -5, T-5, I'm going to cancel everything, then it's not it's a really tough problem to solve. But it's not a technology problem, it's also not a business problem. It's really the government needs to step in and fix some of these issues.
Why is there no discussion about nuclear power, at least for the base? When you talk about renewable... I
mean, so nuclear is one of these things. It's not... See, I have a view on nuclear. I don't dislike nuclear. I just think it's not needed. And I think it's also it's not just me, it's the public. Will you want nuclear in your backyard?
What do you mean it's not needed? I mean, Germany went that direction, right? They
They've
should
gone
not
there.
be-
No, they're not. They're trying to go. I think it's about the public. Like in the same sense, I do think that you can actually get the safety and all that. It's not the safety issue. It's like in the end, people decide what they want, right? So if you can ever get a technology which can be in your backyard, then people can put it just like the solar. If you actually have to build it on public land, then the communities have to decide if they want nuclear there or not. And I think at this point, when I say it's not needed, I do think that there's a path to decarbonization which can be achieved without going to nuclear. So it's not that nuclear is the only option. It may be one of the options, and that's something that different communities will have to decide.
So one last question, then I'll open it up for you guys. So hang on one second. So given this audience, where do you see opportunities, white space in this area? You mentioned that you want these intelligent minds to come at you.
Right.
What are those areas? We just highlighted a couple.
Well, I think there's opportunity everywhere actually right now. There's opportunity in business models and finance, how these assets are going to get financed. So there's all kinds of new services and packaging that can be done. From a technology perspective, this whole intersection of IoT, big data, AI, machine learning, that's extremely ripe because a lot of these business models are enabled by automating the interactions that are happening. And there are so many interactions and they're happening at such micro scale that you cannot get to that unless you're fully automated. But there's obviously some real issues around safety and reliability. It's not that you miss an ad which didn't get served right. It's one thing, you lose some money. If you muck around with your power systems and you cause a big failure in a hospital, people will die. So there are some real high performance numerical computing and reliability challenges which are at extreme when you are dealing with something like a power system. So I think there's a lot of opportunities in that space right now. We are just in the first innings of that right now.
Questions?
Hey, Ashok, can we take audience questions from here so that everybody can hear? We'll take the first question of the person standing there. The rest of you, please line up here meanwhile.
Okay, that's fine. Yeah. But I could repeat it.
That's the first question, right?
Go ahead.
That's your
Go ahead.
Okay.
I'll tell you what, I'll repeat it.
My point has
It'll
to
take
do.
time, so.
No, people will line up here.
Okay. My point has to do with what Venkat just asked about nuclear. Prime Minister Modi was interviewed by Bloomberg just about a week ago on this topic of global warming and climate change and all. And he said that the hang-up for India is it's not non-admission to the nuclear supply. China is preventing it, right? So the access to uranium, that's the hang-up issue.
Yeah. And they are building nuclear plants.
Right.
But that's it. There's other questions? Did you have a
Yeah.
follow-up question on
No,
nuclear?
no.
Okay.
Yeah, my question particularly is about the India case. A lot of this renewable energy power plants. Renewable energy attractiveness is you can actually have a solar plant that's very close to the point of use, and rather than somewhere very far away. And in India, particularly, you can kind of have a power plant that's generating gigawatts, but it's very far away, and you suffer a lot of distribution losses. I don't think that is the best way. They agree that discoms are, since long, they're very inefficient in terms of even the infrastructure is inefficient and people are also inefficient. But given that, don't you think it's also a technological problem? Somebody has to solve the distribution problem as well. Essentially, it's only the production that India is looking at.
Yeah, I think there are lots of problems to be solved, but fundamentally we know how to solve those problems. There's an implementation issue. Like if you look at solar, it doesn't need to be central. It can be central, but just like cell phones, people used to have landlines, and you would wait for a connection for 2 years before you would get now. And cell phones kind of change that. So in the same way, you can put solar on your roof in a lot of cases, and you don't have to wait for the distribution. And even if and it's not that every house has to put solar on their roof before this becomes valid. What happens is that even if 10, 15, 20% of homes or buildings actually have local generation of various forms, it could be solar, it could be other things, then it relieves the pressure on the entire infrastructure, and now you can use that to serve the rest of the population, right? So just in terms, another example I'll give is water use, and we talked about water use also. Right now, power to farmers is free in India, which is obviously a political reality and you can't do anything about it. But it also creates this issue of over irrigation, and that creates water table depletion and all kinds of associated problems. So there's this whole big water power nexus problem that can be solved. And we did a very simple thing in Andhra Pradesh, which was very successful, barring the whole government fiasco, where we put some IoT sensors and we would basically look at the soil moisture and irrigate the farms as much as needed. But we would also do that when the electricity prices were low. Now, if you do it manually, then you will have to go in the fields in the night, and then there's all kinds of risk associated with it. But here, we could do it remotely through IoT, and we would monitor the prices. And the savings to the utility is so high that they can deploy all of this IoT just from that saving. And that actually fundamentally makes these utilities more sort of solvent, because if they're giving them, the biggest reason why they're insolvent is there's so much subsidy, and the government use them as a subsidy. So now if you can reduce that burden, then they become more solvent. So it sort of unlocks this vicious circle that we are in and starts to move it back. So I think technology, I don't want to say that technology is all taken care of, like a lot of people underestimate it, but I think there are bigger business challenges that we also need to address along with the technology to solve this problem.
Sure, it's both a business model as well as a technology problem.
Right.
I agree with
Right.
that.
Thank you.
Thank you.
Any other questions?
Can I ask you from here?
Just ask and I'll repeat.
Just for clarity, Amit, what is your product in AutoBuild?
What is my product? Oh, okay. Thanks. Giving me so our product is a software product. Our customers are energy companies. They can be regulated or deregulated energy companies, and we help them manage their assets and get more money from those assets. So if you have a pool of batteries, or if you have a pool of generators, or if you have a pool of wind farms, we help them monetize them in wholesale markets and all these different arbitrage opportunities that I mentioned to save money.
But it's not just the utilities that have that, right? It's the customers.
It's the customers too.
Yeah. So both regulated utilities, I mean the boundary between utilities and non-utilities is blurring now. I mentioned how large consumers are generating their own electricity, how equipment suppliers are generating their own. So everybody is becoming, what the phrase we use is utility of the future. And so utility of the future is an energy service company, and they are optimizing a whole set of assets, and they are trying to monetize across multiple value streams with different types of assets. So it's, in that sense, it's like an Android basically, like you connect to all kinds of things, all of these things speak different languages, so to be able to bring data and turn them on and off requires you to know what language they are speaking, and then you need to understand all the markets that they are operating in to be able to do.
So it's more the transmission and distribution.
Everything, transmission, distribution, and also wholesale markets, trading of markets. Yeah.
We have time for one more question, I guess. Yeah, go ahead.
My question dealt with the trading marketplace in India. I once heard Piyush Goyal mention that India has a functional trading marketplace. So, do you have any experience dealing with it?
So trading marketplace in India, like a Henry Hub.
Yeah, I think it's all beginning to happen, right? So, I mean, a lot of power is now traded in the wholesale markets in India. Our experience, I mean, we just started a project in India on wind, which is getting traded in wholesale markets. And essentially, like most of the wind farms in India, and like when they first get built, they have a power purchase agreement with a counterparty. And that is essentially 15-20 year long power purchase agreement. So all you need to do is maximize your output and you get paid. So there's not a whole lot of optimization that you need to do. But once the wind farm gets off of PPAs, then it is exposed to merchant risk, and you have to understand what the market prices are and then trade in there. So now a lot of these assets are coming off of PPAs. In Europe, actually, now they're doing almost all zero subsidy wind, where you just have to take the market risk, but in our card you have to do it. But in India also, a lot of assets are coming off of these PPAs, and they're exposed to wholesale market prices. And so that's where, I mean, we sort of work with maybe when we start.
Good. I think we're pretty much out of time, so round of applause.
Thank you very much, Ashok and Amit, for that wonderful keynote session.